All right, welcome back. So we're going to pick up where we left off, which is on part 3 under the fundamental identities from section 7.2. So we have these relationships with our trig functions, right? There's 6 of them. So there are now, by using those, we have some new identities that we can use. And again, these identities are used all the time, so they're ones that you do need to know. Okay, so looking on this chart, we have what are called reciprocal identities, which we've kind of already talked about. Okay, so we know that the sine and the cosecant are reciprocals. So another way of thinking of sine and cosecant, so in other words, sine was opposite over hypotenuse, cosecant is hypotenuse over opposite. So if you're given the sine value, then we know we can just take the reciprocal of it, okay, in order to get the cosecant. So the sine and 1 over the cosecant would be actually the same thing. Okay, so these are reciprocal identities. So cosine is the same thing as 1 over secant. Tangent is the same thing as 1 over cotangent. And then you've got the opposites over here. So those are good to know in case you'll see that coming up in these questions. But so we know those are reciprocal, so these aren't usually too hard to know and remember. Then these are real important. Another way that you can think about tangent is to do the sine over the cosine, okay? So typically, one way to define tangent is opposite over adjacent. Well, you can also look at the tangent. If you know the sine and the cosine values already, you can just divide those, and that will also give you the tangent. Same thing with cotangent. You would do the opposite, cosine over sine. Okay, so it's another way to find these values. And then we have our Pythagorean identities. These all come from the fact that a squared plus b squared equals 1, okay? Oh, that's not true. Equals c squared, right? There's your Pythagorean theorem. Well, when we draw right triangles, the hypotenuse, we usually always have it equal 1. And so this formula is derived from the Pythagorean theorem, but this is the way that it looks in trig. Okay, so we have the sine squared plus cosine squared equals 1. And then these are 2 offsets of that. If you take each of these values up here and divide them by the sine squared, okay, so if I took sine squared and divided by sine squared, I would get 1. If I take cosine squared divided by sine squared, okay, cosine divided by sine, I would get cotangent. And if I took 1 divided by the sine squared, I would get cosecant. So that gives me this bottom. If I take each of these and divide them by cosine squared, sine squared divided by cosine squared, that's over here, is tangent squared. Cosine squared divided by cosine squared is 1. And 1 divided by cosine squared is secant. So by using these reciprocal identities and the quotient identities, that's how I can get all of these. So all of these are considered Pythagorean identities. All right, so we're going to use those and answer some of these questions. So example 4 says, given that the sine of theta is 5/17 and the cosine of theta is 8/17, use the reciprocal and quotient identities to find the values of tangent and secant. All right, so first let's look at the tangent. Since I know that the tangent is sine over cosine, and I already have those values, then I can use those and just find the tangent. So the sine is 15/17, and the cosine was 8/17, okay? So that's 15/17. And remember, when you divide in math, you multiply by the reciprocal of the denominator. So 15/17 times 17/8. The 17s will cancel, so the tangent would be 15/8. So I wouldn't need to use a triangle if I know that that's the same ratio. Now the secant, the next one they ask you for, is the same thing as 1 over the cosine value. Well, the cosine value is given to me, so the secant would be 1 over 8/17, which again is just the reciprocal, 1 times 17/8, which is just 17/8. Now I really didn't need to do all that. I mean, hopefully you know that the secant is the reciprocal from the first few pages, but it works that way just as well. Okay? All right, look at the last one down here on this page. Given that the secant of theta is the square root of 11/3, use an appropriate Pythagorean identity to find the tangent of theta. All right, so I'm given the secant and I want to find tangent. So that means I'm going to be using this Pythagorean identity. Okay, so I'm going to write that down. 1 plus tangent squared theta equals secant squared theta. And I want to find the tangent. I'm given the secant. So if I'm trying to find the tangent, I'm going to subtract the 1 over to the other side. Okay, so that gives me secant squared minus 1. All right, so I am going to put in what they gave me for the secant. The secant was the square root of 11 over 3, but I have to square it because this is the secant squared. And then I'm going to do minus 1. So now I'm going to get the tangent squared of theta equals, if I square both top and bottom, the square root of 11 times the square root of 11 is 11, and the square root of 3 is 9. Since I have a common denominator problem, I'm going to write 1 is 9 over 9. So now I have that the tangent squared is 2/9. And then I'm going to take the square root of both sides. Right? I got to undo that. So the tangent theta is equal to the square root of 2/9, which would be the square root of 2 over 3, right? Because the square root of 2 over the square root of 9, we can break that up. Square root of 2 I don't know, but the square root of 9 is 3. So there would be the tangent of theta. Okay? All right, so these are important to know. Okay, you're going to be using them quite a bit, so just keep them handy, but you do need to memorize them, so hopefully the next day or two you won't need to keep looking back at these. So it's a lot of things to memorize in this unit, in this section. So, all right, now we're going to go to the calculator. So some of the questions that you have, you're allowed to use your calculator. Not many, okay, but if you are going to use your calculator, you need to know how to do that. So I'm going to put the calculator up here for a minute. I'm going to zoom out if I can. Not too much, but all right. So the first thing you need to know about your calculator is you have to be in the right mode. Okay, it says that right up here. So remember that you have modes in your calculator. So if you hit the mode button right here, remember that your calculator is set on radian mode. That is the standard mode for this. So when you're in radians, your calculator is set. But if you're doing things using the degrees, then you have to change to degree mode. So we're going to start off with A, B, and C, which are degree problems. So I have to come down to radian and arrow over. And make sure when you arrow over that you hit enter and that you see the black box around degree. Okay? Otherwise you didn't really do anything. You have to hit enter. All right, so now I'm in degree mode. So I'm going to hit second mode, quit. And now I can do these problems. So we're going to round, let's say, usually with trig you round 4 places. So let's do the cosine. So here's your trig function, sine, cosine, and tangent. So we're going to do the cosine of 48. You don't have to put the degree symbol in because you're already in degree mode. So we would write that as 0.6691. Okay, so round them 4 places. Now, to do the other trig functions, okay, we have to use the reciprocal. But notice there are no cosecant, cotangent, and secant buttons on here. So we have to use the reciprocal identities. So cosecant is 1 divided by the sine, right? So that's the way that I have to do that. 1 divided by the sine of 21. That's what we learned on the page before. So put in 21 like that. And that will give you the cosecant value, 2.7904. All right, the secant is 1 over the cosine, so you would put it in like that. So 1 divided by the cosine of 41, 1.3250. Okay. Now, if you're in radian mode, you'll get an answer, but it's going to be the wrong answer. So you need, it's so important that you put your calculator in the right mode. All right, now, all these numbers are radians. So we're going to go back to radian mode. Okay, so mode, go back to radian, make sure you hit enter. Now we can put these numbers in. Remember, your pi button is right above the caret, right? Second function. So we're going to do the tangent of secant caret to get pi, and then divided by 12. Okay, so that would be 0.2679. All right, the sine of pi over 8, so sine pi divided by 8, 0.3827 if we were rounding. And then the cosecant, remember, is the reciprocal of sine. So to put that in your calculator, you would do 1 divided by the sine of 0.3. So 3.3839, and around. Okay? So pay attention to the mode and pay attention to how many places they ask you to round. Okay? All right, the next thing in your calculator is changing from degrees, minutes, seconds to a decimal answer. So in Trig, the degree measure can be given in two different forms. First form is a decimal, and the second is called degree, minutes, seconds. That's used a lot, back in navigation times when they were sailing. They used this. This is how they broke things apart. So a degree can be divided into 60 equal parts called minutes, and a minute can be divided into 60 equal parts called seconds. So down here you have 1 minute. Okay, so 1 minute equals 60 seconds, and 1 degree equals 60 minutes. 1 minute, equals 60 seconds. I said that backwards. I'm just looking at my writing and what I said, so I'm going to take that back. Sorry about that. 1 degree can be divided into 60 minutes. I knew I said it wrong, but it didn't hit me until just then. And then 1 minute can be broken up, obviously, we know that, into 60 seconds. Sorry about that. Okay? All right. So we have conversion on our calculator to do that. Okay, so I'm going to show you how to do each of those. I don't really ask a whole lot of these, but sometimes they'll show up in Hawks, so just kind of so you'll know how to do them. All right, so we're going to go back to degree mode. So change your mode back to degree. Okay. All right, so get my calculator so you can see it. All right, so if you have a decimal and you want to go to degrees, minutes, seconds, so we're going from degrees, decimal degrees to degrees, minutes, second, then you're going to put that number in your calculator, 22.5. Okay. Then we're going to go to angle, so that's second app. And then you'll see number 4 is degrees, minutes, seconds. So you're going to hit that. So that's going to change this to degrees, minutes, seconds. You hit enter. So there you go. 22 degrees, 30 minutes, 0 seconds. Okay. Okay, 30.25. Go second apps, which is your angle, number 4. So 30 degrees, 15 minutes, 0 seconds. And then lastly, 22.78, change that, 22 degrees, 46 minutes, 48 seconds. Okay? All right. Now, that way is kind of the easy way. This way is not hard, but we got to do a little bit of work. All right. So, let me go over where you find all of these symbols so we can put them in. So if you go back to second angle for a minute, you'll see that number 1 is how you get your degree sign, and number 2 is where you get the minute sign. So when we put these in a minute, we're going to have to use those. What's not in here is the seconds, and I don't know why, but the way your calculator is set up. So the seconds, to get a second, is down here. It's the alpha, the green function, with your plus sign. Okay, so you gotta remember where that is. All right, so if I'm going to put in, so I'm gonna hit clear, Get out of there. So 22 degrees, so 22, and then do second angle and hit number 1. 30 minutes, so 30, go back to second apps for angle and get 2, the minutes, and then hit enter. So 22.5. Okay, and that's degrees. All right, so 30 degrees, so 30, go back to your thing, get the degrees. 12 minutes, so second and 2, so 30.2. All right, now, so the minute one, you just got to remember, or the seconds, how to get there. So we're going to do 22 degrees, 46 minutes, and now we got to do 48. So remember, to get the seconds, you do alpha, the green key, and then the plus sign. So second, alpha, plus sign. Okay? So that gives you 22.78. All right, so remember what I said. When you have a degree problem, you need to see the degree sign. So put the degree sign. If you're doing radians, then you don't have any symbol at all. Okay? All right, so that page just kind of went over what you had to do with your calculator. All right. Okay, so now the last two things we're going to talk about are a couple of simple word problems right now, talking about angle of elevation and angles of depression. So before we start the problem, an angle of elevation down here is an acute angle, so it has to be less than 90, between a horizontal line and a line of sight that looks up above. So basically, you've got a person standing here or something here, and this is their line of sight. Your line of sight is always horizontal, and you're either looking up at something or you're looking down at something. So if you're looking up at something, that would be called an angle of elevation. All right, so if we look at this example, a 28-foot slide, so this is the slide, okay, 28 feet, at a water park makes an angle of 60 degrees with the ground. That would be this, right, with the ground. Here's the slide, and here's the angle it makes with the ground, okay, as it descends into a pool. What is the vertical distance from the top of the slide to the ground? So that means we're looking for this. So when you do these problems, you're going to always have 3 things, 2 of which you'll know, and 1 you're looking for. So you're going to use your trig ratios, and I will tell you, always use sine, cosine, or tangent. Don't ever use the reciprocal ones because you don't have those buttons on your calculator and it makes it harder to find. Okay? So look at your angle, 60. Look at your 2 sides. This is the opposite side and this is the hypotenuse. So we want to use the sine formula because that is opposite over hypotenuse. You don't want to use cosecant because again that's not on your calculator and you're going to make more mistakes if you do that. So just use one of the buttons that are on your calculator. All right, so then we're going to fill in what we have. We have the sine of angle 60 equals the opposite side, which I don't know, over the hypotenuse, which is 28. All right, if I have all my things except one, I can solve for them. So I'm going to multiply the 28 over to this side. So that's 28 times the sine of 60. So that'll give me x. So again, make sure you are in the right mode of degree, otherwise you'll get the wrong answer. So we're going to do 28 times the sine of 60, just like that. And so that would be our answer, 24 point, let's call that 25. Okay, we'll just go ahead and say, we're rounding, it didn't say what to round. Okay, so that would be feet. Okay. Again, when you're in Hawks, pay attention to how it wants you to round, okay? All right, so the next problem, the last problem, is just using angle of depression. So these you got to be careful of. So remember, you're always going to have the horizontal, and then you're going to look down, okay? So this is where some of you will make some mistakes. So let's look at this problem and label it correctly. So we have an observer on the roof of a 40-foot building. Okay, so here's our person up here. And this is 40, right? This is the building, straight up and down. All right. Measures the angle of depression from the roof to a park bench on the ground to be 24 degrees. All right, so here's the bench down here. So when he's looking at that, he has to start from a horizontal line. And he's going to look down on that bench. So this is the angle of depression, which is 24 degrees. Okay? So if this is 24 degrees, you're needing this angle right here. And remember, this would make a right angle. So these two angles have to add up to be 90 degrees. Okay? So that means this one would have to be 66 degrees. So students a lot of times will put the 24 there, but I will tell you, and as we do these problems, an angle of elevation or depression always starts from the horizontal. That's your line of sight, and then you either look up or you look down from there. Okay? So 66 plus 24 is 90, so I need that 66 degree angle. So now it asks us, what is the distance from the base of the building, this is the base of the building, to the bench? So that's what we're looking for. Okay, so we're not going to use 24 degrees in this problem, we're using 66. So look at this angle, you have the opposite side and the adjacent side. Here's your hypotenuse. So this is a tangent problem. So the tangent of theta, remember, is opposite over adjacent. Okay, so we're going to fill in what we have. We have theta, which is 66 degrees. We have the opposite side, which is x, and the adjacent side, which is 40. Again, we're going to multiply the 40 over here to solve for x. And then we just put that in our calculator. So 40 times the tangent of 66. So you see how much easier it is if I'm using tangent, sine, or cosine. So don't use the reciprocal ones. Use your main three. So we get 89.84, and this was feet again. So that's how far away the bench is from the building. Okay? All right, so please be careful with angle of depression. Watch where you put your angles. It's very easy to make a mistake. So draw your picture, draw the right triangle, label your stuff, okay? Might seem simple enough, but you know, time you need to make sure you're using the right angle. Now, angles of elevation, you usually don't have that problem because you're starting at the bottom and you're looking up. So these are the ones that you just got to be careful how you set it up. Okay? All right, so that does it for 7-2. So you got all your notes now. Work on your homework. Email me if you have any questions. And I'll see you back here for section 7-3.